So what is direct georeferencing? Well, as the name implies, we measure position orientation of an imaging sensor, and we use that to directly geocode each pixel or point from an imaging sensor in real-world geographic coordinates. The imaging sensor can be LiDAR or a camera. The technique is pretty much the same. So we use the data from the position orientation system along with the sensor data such as the LiDAR range or the camera orientation, and we use it to directly geocode each pixel or point on the ground. And this can be done without any ground control points. It's important to realize, though, that direct georeferencing can be used with any type of imaging sensor, but it must be used with those scanning type sensors such as LiDAR, SAR, and hyperspectral scanners. So what are the components of a direct georeferencing system? Well, first you need a high-performance, multi-frequency, multi-constellation survey-grade receiver. You need an inertial measurement unit for computing orientation. You need a high-performance, low-noise GNSS antenna. And you need the algorithms. You need the real-time and post-processing software to blend all this together. But very importantly, you need a GNSS augmentation system to correct the errors down to that centimeter level positioning that you need to do the direct georeferencing.